So for our project, we have done a population sensor for any kind of enclosed space with single entrance or exit, like a classroom. We were going to use motion sensors, the PIR sensors, but we couldn't get those working. All models are wrong, some are useful. We're modeling that using these buttons on the carrier sensor instead. So when you activate the first sensor and then the second sensor, it adds 1 to the count. If you activate the second sensor and the first sensor, that's somebody leaving. So that updates the count, and that goes through our dashboard. It's reflected in the cloud variable, and we can track the history of people entering and leaving a space. Good morning, welcome to class. Got you logged on there. Good morning, good morning. There you go, motion sensor picked them up.
Professor.
Good morning.
Good morning.
I like the energy. There you go. Motion sensor picks him up as well. We're at 3. Looks like the sensor missed 1, so we can manually add a 4th.
Good morning.
And good morning. And 5. So yes, today we're going to be working through a couple assignments on packet tracer. A lot of this stuff is going to be really helpful for you guys to learn how to operate server racks and stuff like that. Looks like we lost a student, so I can manually subtract somebody from our account, and it'll have a timestamp of when that happened. Cool. All right, class is over. Have a good day, everybody. Looks like the sensor missed 1, so we can subtract there. And then
Have a good night.
Have a good night. Should just work cleanly for everybody else.
All right.
Perfect. Still going down. All right, have a good weekend.
All right. You too, Professor.
Perfect. And we're back down to 0. Nobody here. I accidentally walked past the sensor, and there's 1 left in the count, so we can press this handy reset button, put it back to 0. All right. So here I'm going to be giving kind of a technical overview of our project, walking through the Arduino cloud resources and kind of going from the bottom up through, everything our project is sort of doing here. So the first kind of level of this is the actual board, the device, the Arduino MKR Wi-Fi 1010. Onto this device, well, first of all, it's connected to the carrier board, which has our screen as well as our sensors, which again we're using our touch sensors to model the non-functional PIR sensors, or at least the PIR sensors we couldn't get figured out. Onto this device, we have loaded some code, which essentially is constantly monitoring these sensors and also connecting the board up through the internet and into the Arduino cloud. Goes up through whatever Wi-Fi access point it is on campus. Verifies credentials, goes up through the building access into the broader UMD access point, and out through the broader internet until it reaches whatever AWS server this cloud system is hosted on. And on this cloud system exists a thing, which is essentially a digital representation of this device that allows for a lot of things like updating this code through the cloud, but also the storage of cloud variables that are rendered independent from any local storage on the device. And on this code, we're essentially constantly monitoring both the sensors, but also this sensor counter value in the cloud. And every time the sensors detect a change, it sends that change up to this cloud variable and alters it. And this not only allows remote monitoring and interaction through our dashboard, like we demonstrated in our project. We use tracking and remote modification of the variable, but it also allows us to potentially scale the system much easier to multiple devices interacting with this one variable, as we kind of outlined in our Miro project. So Yeah, that's pretty much everything.
This is our Miro board. We started off with research. We all looked into projects, sensors, IoT system examples. We then went on to create 2 personas. So we started off with a farmer to keep track of cattle population or overpopulation to help a farmer. And then we stuck with persona 2, which was a college professor needing to keep track of how many students are attending their class. We did research on this persona, possible problems, keeping tabs on which students are attending lectures or having, a guest lecture and needing to make sure kids are showing up. And having a PRS sensor and a screen sensor to keep real time track of who's there, how many people are there. Then we have a storyboard of their life. We analyze their ups and downs throughout their day, waking up, class time, post-class, end of day, late night reflection. We have our user story Mad Libs with receiving accurate counts without having to manually count themselves and gaining accurate insight to then be able to give credit to who's showing up to mandatory class. We have our Mad Lib brainstorm right here. Then we have our Arduino IoT cloud system with prototype, so we can see live attendance, student details, summary, and alerting based on attendance reports. We have the sequence diagram, so we can see the PRS sensors, controller, how it works with the app, all connected right here. This is our packet tracer, so we can see how the cloud, Wi-Fi, sensor, and app all work together right here, as well as all right here. Then we have our persona might react to our screens right here, and here is our diagram, which goes pretty in depth. And then lastly, we have our business prototype all right here. Thank you.